In this video, we're going to solve the last three questions on our practice test. So C4 here, numerical techniques, we're asked to use the rectangular method with n equal 4, so using 4 rectangles, to approximate the value of this integral. So we'll start by writing our formula. The area is going to equal delta x multiplied by the function values at our initial point, which in this case is a. And then we're going to have three other points, and they're going to be a plus delta x, a plus 2 delta x, and a plus 3 delta x. And we know that because we need 4 altogether, 4 rectangles, so if we add delta x 3 times, that's our other 3 rectangles, as well as our initial one. We don't go right to the end using rectangle method. That's only for trapezoid or Simpson's rule. So now we need to find delta x. Delta x we know is b minus a over n, which in this case is 2 minus 1 over 4, or 0.25. Of course, this here is a and b. Now it's just a matter of evaluating the natural log of x at our required points. So the area is going to equal delta x, which is 0.25, multiplied by f of a means the natural log of 1 plus the natural log of 1.25 plus the natural log of 1.5 plus the natural log of 1.75. And so there's our 4 rectangles. We evaluate each of those, add them together, multiply by 0.25, and we get the result 0.29705 units squared as our area. So that's our approximate area using the rectangular method. We'll continue now to C5. And C5 is an electrical application. So we're told the initial voltage across a capacitor is 0. So let's on the side write down what that means. That means the voltage at time 0 is 0. So there's one piece of information from this first little section of the sentence. And V of C equals 2.5 volts after t equals that many seconds. So that's another piece of information. The voltage after 8 times 10 to the minus 3 seconds is 2.5. So there's a second piece of information. That's that first line. We're told if a current I is equal to this, and I is in amps and t is in seconds, charged as a capacitor, we want to find the capacitance C of the capacitor. And we're given this formula here. So volume equals 1 over C times the integral of I dt, and well, we know I, so let's put that in. But we know I is this, that's times dt. Now we're going to use U substitution to integrate here. We'll write the steps. U is the root, du is 2t dt, but we don't have 2t. We need du over 2 is t dt. So substituting then and integrating, we find that the volume is, or not the volume, the voltage is 1 over c. We're going to leave that outside and put this in big brackets, and when we integrate, we get 1 over 2, and that's from the du over 2. This is our u, so this is going to be u to the 1 over 2 minus a half plus 1 over 1 over 2 plus k here, constant. We're just going to use k instead of c so we don't get confused. And then we're going to say, well, we know that v of 0 is equal to 0, so v of 0 equals 1 over c. Half and half here cancel, so we end up with t squared, or 0 squared plus 1 to the half plus k. And if we go ahead and solve, and that's going to equal 0. So now we can go ahead and solve that for k, and I'll just go quickly. That's k equal minus 1, which tells me, well, that v is 1 over c times t squared plus 1 to the power of a half minus 1. So there's our equation for voltage, but we need to find the capacitance here. Well, we have a second piece of information. We know that if we put 8 times 10 to the minus 3 in for t, we get 2.5. So we're going to go ahead now and use that, and we'll try to squeeze it in the side here. So we know that 2.5 we're going to get if we say 1 over c multiplied by 8 times 10 to the minus 3 squared plus 1 all to the power of a half minus 1. And we can take the c over to the other side, which basically means that we get c, or 2.5 times c, equal to all of this. So when we square this, add 1, take the power of a half, and subtract 1, we get 3.2 times 10 to the minus 5, divide by 2.5, and that tells us the capacitance is 1.28 times 10 to the minus 5. So there's the capacitance. And the last example then, C6, where we have 3 parts in this motion application, and each part we're asked really to find a function. So we know that Hammond stands on a ladder 6 meters above the ground. So that first line, well, that tells me that at time equals 0, the position, or in this case the height, is equal to 0 meters. And he throws a rock into the air. The acceleration due to gravity is this. So acceleration equals negative 9.8 meters per second squared, as we expect. And the initial velocity, so at time 0, is this. So again, at time 0, h is this, but also v is 29.4 meters per second. And you should actually see here the pattern that we're going to be using. Acceleration is going to lead to velocity, is going to lead to the height. So write an equation for velocity. Well, we know velocity is the integral of a with respect to t, which in this case means the integral of negative 9.8 dt. So v equals negative 9.8 t plus some constant. And since we know v of 0 equals 29.4, then we know the constant c is 29.4. So in other words, velocity as a function of time is 29.4 minus 9.8 t. So there's the example A. There's the velocity. Now we need to write an equation for the height, and we'll try to leave the velocity equation there so we can see it. Equation for the height, well, height or position is going to be the integral of v with respect to t, which in this case is the integral of 29.4 minus 9.8t with respect to t. And if we integrate that, we get 29.4t minus 9.8t squared over 2, or 4.9t squared. That's 9.8 divided by 2. Again, plus some constant. And this time, we know that h of 0 is 6, which means if I take this equation and put in 0, and I'll write the step even though we shouldn't need it, we see that everything disappears and it turns out that c has to be 6. In other words, h of t is equal to 29.4t minus 4.9t squared plus 6. The final question then says, what is the height of the stone at 5 seconds? Well, we know that the height is given by that function, so at 5 seconds, that's going to be our height. So we just replace t with 5 there. And we put in 5 squared plus 6. And if we work all that out, we get 30.5 meters as our height after 5 seconds. So there's our 3 pieces there. So that's the end of the practice test in those 3 videos. I hope that you can understand the explanations, and I hope that you can understand the questions, because these will be a good review for the test you have coming up.